I'm going to share with you a couple of examples of my experience of BIM for railway, and I'm going to share with you my way of approaching the adoption of BIM. And it is quite simple. I try and define a problem. So as the first speaker has said, there is a problem with BIM. So there's a problem with the software, there's a problem with the resources, there's a problem with the training. So we identify what the problem is, and then we try and determine the solution. So sometimes a solution requires training. Sometimes a solution requires standards, specifications. Sometimes it requires a change in the contract so that the contractor does something a bit different. But we start with the problem and then we try and find a solution. So my presentation today is in three parts. The first part, I will share with you very specific examples of how BIM can be used for Metro. And then I'm going to share with you my experience of why BIM has failed on some of those Metro projects. I'm then going to show you how you can link BIM from the computer model to the construction project. So how do you actually monitor the project by linking the digital world to the physical world? And I'm going to show you two different ways of doing it. One is to go to the construction project, make a video, make a photograph, and bring that back to the model and check the model. And the other is to actually bring the model to the project. So bring the 3D model into the construction site and explore what's happening in the construction site. If you can link the digital world to the physical world, you can get a lot of value from the process. But if you keep them separate, you don't get the value. So this is the purpose of today's presentation. Oops. I have an English version here, and you have the Vietnamese version here. And the English version just so I can remember what I'm supposed to say. So the way we approach this in our company is that we provide three different observations, three different types of report. So as an owner, the first thing you do is appoint a design team, the architect, the engineer, and you need to know that they're doing it correctly. From my perspective, the only way the architect can succeed and the only way the engineer can succeed is if they produce the model first and then produce the drawings. In many, many projects that we see in China, in Asia, in Malaysia, they make the 2D drawing and then they give those drawings to another company and they make a model. That is not going to work in the long term. We have to train the architects, we have to train the engineers, make the model first, and then produce the drawings. So we can help identify those processes, identify those systems. Once that process is working, we can then give you an assessment of, is it good quality modeling, is it not good quality modeling? So how much coordination is to be done? And then ultimately, when we get to construction, we have to monitor the contractors. How are they producing the models? Are they modeling to produce shop drawings? Are they modeling for quantities? So we have to monitor the system all the way through. So I'm going to share with you some examples from a metro project in Malaysia. This is the LRT in Penang, which is now under construction. So as I say, for the architect should, through experience, be confident using Revit and those drawing tools. Most architects nowadays have been trained to use these tools. As an owner, the first question you should be asking is, have you got enough software? Have you got enough staff? But the most important question is, are you producing your drawings from the models? Because if the drawings are not coming from the models, you're not doing BIM. The same is true for the engineer. So for those of you who come from an engineering background, the structural engineers, so I'm a civil structural engineer myself, the structural engineers are very used to working in 3D. They do 3D structural analysis, they do 3D structural calculations. It's a natural thing for them to work in 3D. The limitation is they say, we don't have enough training, we don't have enough staff, but ultimately the engineer, the civil engineer, it's easy for them to work in structural 3D models. And the same is true for the civil engineering. So for the viaducts, for the tunnels, they have less experience. So when you start off implementing BIM, most people will do it for the stations, but then they will forget to do the viaducts and the utilities. So again, the civil engineers can be trained to make the models. They can be trained through the coordination. The problem with BIM in design is the mechanical electrical systems, and in the case of railway, the railway systems, the communication systems, the track work systems, the signaling systems. The design engineers do not have experience of doing 3D modeling, and they do not have experience of doing coordination. Are we okay? It's okay? Okay. So when you are managing the project as MRB or as the main project manager, being aware that the building systems, the mechanical systems, the electrical systems, the plumbing systems, the railway systems, this is the most difficult thing to get correct because they have the least amount of experience. And then when you put them together, you have to manage the overall coordination. So the secret to making BIM successful is you have to arrange coordination meetings. In my case, we do it every 2 weeks. So we allow the architects to work, we allow the engineers to work. Every 2 weeks, we bring them together. And we have a coordination manager for each package of work. So we have a coordination manager for a station or 2 stations. We have a coordination manager for an elevated section of works. Each section of the works, each package of the works must be coordinated. And it will not happen by accident. So you cannot rely on the architect to do it because they don't coordinate mechanical systems. You cannot rely on the structural engineer to do it because it's not their responsibility. So somebody in an MRB has to drive the coordination. And this is where you have to start thinking about your contract. Who do you make responsible to do the coordination management? Who do you make responsible to check that all these models, when they're put together, fit together? So coordination is a very, very, very important thing. So this is just another example of the same thing. Okay, so these are combined models. So the way we've done it in the past, first of all, I have not seen any of the documents that MRB are using on your project. So I cannot comment on what you're currently doing. This is how I have done it in the past. So we set up a management plan, a BIM execution plan. And that plan has to be very specific for each package of works. So each package has to deliver their management plan. Who is on the team? The names of the people, their phone numbers, and their emails, right? Not generic roles, but the actual specific people that are responsible for BIM have to be named. For each person, we name all their responsibility. So for the architect, what do they do? For the engineer, what do they do? So each person's responsibility is defined. And then we work on our collaboration strategies. How are we going to exchange information? How are we going to share models? How are we going to share drawings? How are we going to fix coordination issues? And so on and so forth. So this coordination or BIM execution plan is very, very important. And at the very bottom, you can see it includes the standards and guidelines. So you can include all of the MRB requirements into this document. So my ambition is that we get BIM right. We get the basics right. And when I say get the basics right, I've already said it once, the design drawings must come from the models, right? And if that's not being achieved, it's very difficult to elevate the team to do other things. Because if the drawings are coming first and the models are coming next, the quantities cannot be the same, the extraction cannot be the same, the schedules cannot be the same, and then you cannot rely on the models because what will happen, the architect will change the 2D drawing, they will issue the 2D drawing, and then the model is no longer correct. So if the drawings are the wrong way around, the model is less valuable. So when I say getting it right, I mean you start with the models. Then you do the coordination, then you can do your scheduling, etc., etc., etc. So where am I at? Here we go. So let's talk about BIM and let's talk about some of the fundamentals. This is a coordination process that is in every plan that I've ever written, and it is a cycle. So you start off building the models, then you identify the issues, then you have a meeting, then you organize a workshop to solve all the issues. And then the most important part of this process is that if I find a problem and Mr. Trung is responsible for fixing it, we agree that Mr. Trung is going to fix the problem. He's going to update his model. He's going to move a door. He's going to fix the pipe work. He's going to fix something. and we agree a deadline. So we agree it's going to get fixed by the next meeting, it's going to get fixed in a month's time, it's going to get fixed in a couple of weeks' time. We project manage this process. So we have this meeting. So this is a typical coordination meeting. So the model is the center point, the model is the discussion point, and you have a coordination workshop. You're looking at all the different systems and the interaction between the systems. You can do it on a level by level basis. You can do it on a station by station basis. It's up to you how much you can do. But the first thing you have to do is you have to document this. So we use two different software. We use Navisworks or we use BIM Collab. And I saw in one of the presentations, I think you're using BIM Collab. But essentially, you track all the issues. You track where the issue is found. You track who is going to fix the issue. One person. So it's not a committee. One person's responsible, and they're given a deadline, a date. So this is how it looks like in this particular piece of software. So that's the first thing you have to get right. You have to get the coordination process correct. As the owner, you don't have to do the coordination process, but you have to make sure it's happening. You have to make sure that people are actually every 2 weeks looking at the models. And what's most important is that it's the engineers and the architects that are looking at the model, not the BIM staff. So the people who've been trained to make models don't always have the same experience of construction. In fact, most of them don't understand construction at all. They know how to make a model of a staircase, they know how to make a model of an escalator, they know how to make the model of a fan coil unit, but they don't know how it gets built and they don't know how it gets installed. So it is very, very important that the coordination meeting is run by the engineering team, the engineering coordination team. It's not a BIM meeting, it's a design coordination meeting. That's very, very important to understand. So once you've got this process figured out, you can then track all the issues. So we've used BIM Collab in the past. So I can start to track the number of issues per package. I can start to track the number of issues per engineering team, and I can start to monitor their performance. So you can get a report every 2 weeks, every month, how many issues are being resolved, how many issues are outstanding, which team is performing, which team is not performing. And you can get a glimpse of what's going on in the design. So these are very important tools, again, as an owner, to manage the coordination process. And then once you've got the coordination done, then you can get into the drawings. So the first test of a design team is that they produce a standard drawing, but they also start to include 3D views. So this is a good example of being a bit innovative with drawings. You can get the design team to work in color. There's no reason to have black and white drawings, particularly in a digital environment. So you can start to demand that I want a color-coded drawing for the MEP. I want to be able to distinguish what is air supply, what is air return. Oops. You can use it to create schedules. So as you start cutting out the drawings, you can start creating schedules. So this is very useful for engineering reviews. But what's most important, and this is a challenge I'm going to set for you, on your next project, don't just settle for traditional 2D drawings. The plans, the elevations, the sections, that's easy in Revit. Also ask the design team to include isometric views. And you can do it like this per plant room, you can do it per level, you can do it in sections. But if you start producing these 3D views, you get more value from the process and more people will understand what's happening. So you can produce any number of 3D views. Apologies, Mr. Chung. I added these slides in this morning, so these are all in English. So we can translate them after this. One of the other important things as an owner from BIM is that when you speak to people like Crossrail, when you speak to people like in MRT in Malaysia, ultimately what we want is we want a digital twin of the railway. So ultimately, at the end of the process, we want a digital twin of the railway. And the only way to achieve that is to actually classify the systems that we need to actually maintain. So I don't know, again, maybe in the next couple of months we can learn, but in terms of MRB, I don't know how you manage the railway. So I don't know who runs and operates the railway. But in order to be able to do that, you can start to collect operations information during the construction phase. And the way we do that is we establish each station as an entity or a location. inside each station, do this behind my back, we have spaces. So you can have a concourse space, you can have an entrance space, you can have a platform space, you can have a plant room space. And inside those spaces, you have systems. So you can have a communication system, a fire system, an air supply system, an air exhaust system. So each station gets set up with the station, the space or the room, and then the system inside it, and then the actual piece of equipment. Oops. So each piece of equipment then has that identification. So what you're doing is you're classifying every piece of equipment in the building so that when you look at that piece of equipment, you know what room it's in, you know what station it's in, and you know what system it belongs to. And then you can start to build up your maintenance and management system. And ultimately, you can use the BIM system to collect all the information for all the different products, and you can specify as the owner what data you need for each system. So if you're collecting pumps, pump rates, power consumption, volumes, etc. If it's fans, different data. If it's escalators, different data. But you as MRB should be able to create a requirement that you give to the contractor and that they deliver the information. But do not make the mistake that they made in Crossrail, where they said, we want everything. Don't do Kobe. Don't go after the big stuff. The tip I will give you is the same tip I got. Put the data on a diet. And what I mean by that is collect the least amount of data possible. Okay? So for each product, identify what is the data you actually need for an operation system and only collect that data. So that you don't have to collect thousands and thousands of bits of data, because then you have to check thousands and thousands of bits of data. So only collect the data you need, and then you have value. Excuse me. Okay, so we're missing a symbol, not to worry. Should be the next one, I guess. Yeah. Okay, so that's my kind of tips on BIM. Model first, draw second, use the coordination process and drive it as MRB, and then start to classify the data. Now I'm going to move to making value from BIM during construction. Most of the projects that I've seen in the last 20 years, the BIM team live in a different world. They often live in the engineering office. Sometimes they're hiding in the corner of the site office, but they're never on the project site. You don't see the BIM guys walking around the construction sites. Okay, I want to change that, and MRB can change that. So I'm going to share with you a number of technologies that allow you as the owner to bring BIM to the construction site in two different ways. So the first way is to actually bring the site to the office. So I'm going to share with you three different ideas: laser scanning, drones, and 360 cameras, and I'll share the differences. And then I'll show you how to bring BIM to the project. So this is a laser scanning, oops, going back, I've got two different presentations, English and Vietnamese. This is a project we did in Hong Kong. So just for a quick bit of background, I'm Irish. I spent the first number of years of my career in Ireland. In 2000, I moved to Hong Kong. I spent 15 years working in Hong Kong as an engineer. And then my wife is from Malaysia, so we got married in Hong Kong and we went back to Malaysia in 2015. And I've been living in Malaysia since 2015. So I've spent 25 years in Asia, mainly in Hong Kong and in Singapore and in Malaysia. This was in Hong Kong. This is a cargo facility for the airport. But I just want to share with you what we were doing 15 years ago as an example. When we started doing BIM for construction, we would go on the job site with a camera and take photographs of the project, and then we would go back to the office and try and find the same position in the model. And then we would make these comparisons. And it was like playing spot the difference. So looking for changes, looking for differences. Oops. What's going on here? It's catching up. Okay. Later on, we then went to the actual airport terminal. This is a very complicated steel building. And the first thing we did was the steel detailing. So again, this was done by the contractor. I was working for the contractor. We did all the steel detailing for the project in Tekla. We included all of the systems. So we included the systems inside the terminal and we included the systems external. So this is the inside of the ceiling system. and this is the actual cladding system on top of the roof. This idea applies to railway stations as much as it does to airports. So when you're designing the roof of the train station, when you're designing the platforms, you need this level of detail for the construction phase. And then this is the MEP system inside. So one of the challenges on this project was we needed to survey the steelwork. We needed to make sure the steelwork was installed in the correct location. And because it was curved and it was complicated in shape, we decided to use laser scanning. So laser scanning basically captures the site condition as millions and millions of points. So you can see here, this is the actual scan of the steelwork. So this is basically a method of surveying the actual project, and then you get a 3D model from the project. And the advantage with this is it's very, very accurate. It's plus or minus 5 millimeters accuracy. So you have a very accurate survey. It's very quick. And then what you can do is you can combine the survey from the site with the fabrication model. So you can start to compare the installed steelwork against the shop drawing steelwork and make sure they're correct. So what that looks like, the green is the laser scanning. And you can see we can check the position of the steelwork against the actual pipes. Now, every time I show this presentation, people go, well, that's for curved steelwork. It's for complicated. It's not for my project. Here's a different example. This is a very simple structure. This is the link bridge. It's a steel frame, traditional steel frame truss. And we surveyed this with the laser scanning to check the connection between the cladding system and the steelwork. So again, get this to work. This video is basically the 3D scan of one of these link bridges. We did this 25 times. It was 25 link bridges. So this is basically a 3D model from the construction project from the laser scanning. So again, the green is the point cloud and the red is the structural steel model from the detailing. Come on. So I can actually go right down to the detail and I can check if the steel plates are in the right position, if they're in the right level, and everywhere they're not correct, I can raise that as an RFI. And it can be a correction for the fabricator to make, or it can be a correction for the site team to make. But it's a very, very good way of finding problems on the site. And by finding them this way, I don't have delays on the project. I don't have to wait till somebody finds it by accident. So this is a very accurate way of doing surveying. It's a very powerful way of doing surveying. It's also expensive. So the laser scanning hardware can be as much as 50,000 US dollars per piece of equipment. So it's expensive technology. So that's the one downside, is if you need the accuracy, it's very valuable. But if you don't need the accuracy, it's very expensive. So I have a solution for you. 360 cameras. How many people here anybody here got a 360 camera or used 360 cameras? Not yet? So a 360 camera is about the same size as maybe about this in terms of the bottle of water. It's not very big. They're very, very useful, but they're less accurate. So this example is from a particular vendor. This is from Cupix. So it's the same idea. So you have a camera on the worker's helmet. He's just walking around the project. There is an app on the phone, and the app is tracking their position. So you can see the position on the keyframe. So as you're walking around the project, you can be underground, you can be disconnected from the internet, and this will still work. You don't have to be connected to the internet, and it will record 360 degrees. So it's creating basically a 3D model of your project. You can use it to get into the upper levels, so you can use it for mechanical checking, for pipe checking. And at the end of this process, you have a 3D model from the project. This one. So you can take your model. This was an example from Autodesk Construction Cloud. And you can have basically the 360 video or the 360 image on the left, and you can compare it to the model. And as you move, it knows where you are. So it changes the camera. So if you're inside the plant room, as you move through the 360 image, you can see the 3D model changing as well. So you can visually compare what's happening on the project to what's happening in a model. So if you have a good quality BIM model, you can then use it to monitor your construction process. You have to have a good model, otherwise you get a big number of mistakes. The best part You can take objects from the 3D model and you can impose them into the Site 360 models. So you can actually predict where something's going to be. So you can put steelwork in, you can put ductwork in, you can put pipework in. So you can see what's going to happen next or what's going to happen in the future. So again, as a project management team or as a client team, it's a very powerful way to actually supervise what's happening in construction. Excuse me. So that's 360 cameras. The last thing I'm going to share with you from a capturing the site are drones. Most people buy a drone, they fly the drone, and they take lots of photographs. And sometimes they take some video. And I'm pretty sure MRB have done it for marketing, for PR, et cetera, okay? That's great, fantastic. But if you own a drone, you need to understand that it's actually a very powerful surveying tool. It's a piece of surveying equipment. So how does this work? So as a drone covers the ground, you can take hundreds of photographs, overlapping photographs. So each photograph includes 70% of the previous photograph. And as you go along, those photographs can then be used to create a 3D model of the project. So this is very, very good for elevated structures. It's very, very good for civil engineering projects. And from these photographs, skip this one. Oops. Just 1 second. I'm going too fast on the clicker. Is that going to work? No. So you can set up the track for the drone and it will fly the same path every time. And then once you've collected all the photographs, the first thing you can produce is a proper two-dimensional, we call them orthomosaic picture of the site. This is dimensionally accurate. So I can use it as a background for my models, I can use it in my GIS system, and I can use it to monitor things. I can then create 3D models. So this is a 3D model of a TBM launch shaft in Kuala Lumpur. And it changes every month. So you can see the progress month by month by month. Okay? These are models. So I can measure the volumes, I can measure the heights, I can measure distances. It's a 3D model of the project captured by drones. The best part is that I can overlay this 3D model of this construction shaft. So this is the actual TBM arriving in one of the station boxes. I can overlay that with the BIM. So that's the mesh from the drone. So that's what the model looks like from the drone. I can turn on the 3D model. Here it comes. Here it comes. There we go. So that's the 3D structural model with the drone footage overlaying. Now, that's interesting, but it gets really useful when you start seeing it in sequence. So this is basically month by month by month. So you can see the progress of the excavation. So you can monitor the contractor's progress. You can calculate how much volume has been removed, and you can calculate how much volume remains to be removed. So you can use this as a construction surveying tool, and you can use it for monitoring the progress of the project. Just by flying the drone once per month, you get some very, very valuable data. The contractors who've done this now fly the drone every week, and they have an update every week of what's happening on the projects. So I'm not recommending it every week when you start off, but at a minimum, start once every month. But again, you need the model to get the value from the drones. So as you unlock BIM, as you get better at BIM, you can start to use these technologies to see what's happening on your site and compare that to what's in your models. And then you start to get more value from the whole process. So those examples are basically, skip this, those examples I've shared with you are when you go to the project and you bring the data back to the engineering office. What about when you want to actually go to the site and you want to see what's going to happen in the construction process? So this is where augmented reality comes in. Now, I've put in a picture of a guy wearing a helmet. This is an XYZ helmet where you have to wear this thing. I do not recommend this. These helmets are very heavy. You need to be a Formula 1 driver with a very strong neck, and then you maybe can work for 20 minutes, half an hour. What I do recommend is using an iPad. So here you can see an operator. They have the structural steel model included on their iPad, and as they move around, they can turn on and off the model. The iPad knows where it is, and he can see what's going to get built in the future. So the 3D model is in the device, and it knows its position in the real world, and you can see what has to get built. Maybe it's a TBM launch, maybe it's a concrete structure, maybe it's a steel structure, or maybe it's a piece of ductwork. The advantage is that you can use it to check things before construction. So in our experience as a contractor, building metro, you build the walls. Sometimes these are 600 mil thick, sometimes these 800 mil thick. And you put all the pipework penetrations, the cable work penetrations